Today we continue with the fundamentals of remote sensing, lecture number 8, types of images. Remote sensing images may be available in hard copy, that is paper print, or soft copy, that is a digital form. Panometric remote sensing images. What to understand by panometric remote sensing images? Reflected energy sent by the single sensors for each pixel. That single band normally varies from 0.4 to 0.7 micrometer. It may have radiometric resolution of 8 bit. These images are known as pan images. These images in black and white color, that is gray color. Data contains one layer of values in grid of rows into column. The next one is multispectral remote sensing images. Each area of Earth is sensed by two or more than two layers of sensors. Hence, clarity of the images increases. Arrays of the sensors are arranged. Spectral bands range from visible to short wave infrared. That means spectral band का range कौन सा है? Spectral band range from visible to जो short wave infrared है वो remote sensing images में वो cover होता है. Okay. Some systems may add 1 and 2 bands of thermal infrared region of the spectral. Data will contain more number of layers of values. Then next one is hyperspectral remote sensing images. Each area of the Earth is sensed by hundreds of layers of sensors in narrow spectral bands. Sensors comprise of imaging spectrometer. Spectrometer have ability to measure energy in bands of narrow as well as wide spectral bands. The next one is digital images. Pan images are 2D array of values, while the multispectral and hyperspectral images are 3-dimensional array of the values. Each value is brightness value. Brightness value of each pixel is represented by a digital number known as DN value. DN value may vary from 0 to 255 on 8-bit radiometric resolution. Interpretation keys. What do you understand by interpretation keys? The interpretation keys are developed using the elements of interpretation, that is shape, size, then shadow, pattern, texture, tone, color, association, etc. as well as the altitude of the orbit of satellite, orbital plane, time and session of the exposure. Interpretation keys for some objects are as follows. Barren land. Barren land appears light grey, sandy areas appears white to bright white. Sandy area is associated with the seashore or deserts. એટલે interpretation that means what? जो भी हमें दिखाई देता है वो हम इंटरप्रेट किस तरह से करें या कैसे कर सकते हैं. इंटरप्रिटेशन दैट मीन्स ઓળખવું. એવું કહી શકાય કે ભાઈ આપણે કોઈ एरिया जब भी कोई एरिया है उसको वो क्या है वो इमेज से पता लगना चाहिए, तो दैट इज कॉल्ड इंटरप्रिटेशन. Wetland located on the periphery of the water bodies appears dark grey. Floating vegetation on water body appears in red tone. Black tone for the water. तो जो भी इमेजेस है उसको अलग अलग कलर में इंडिकेट किया है. Then snow and glacier. Snow has a high reflectance in visible light and hence appears bright, but is having low refractance for the wavelength larger than 1.2 micrometer, hence appear darker. To differentiate snow and cloud, middle infrared image is used. Then next one is railway oblique road. Rail lines have smooth curvature, roads have abrupt change in the direction. Concrete surface in light tone and asphalt bitumen road appears in the dark zone. Airport can be recognized by large area covered for the hangars, terminal buildings and runways. Seaport and railway terminals can be recognized by associated shape and characteristics. The next one is urban built-up area. Urban area is associated with the road network with the man-made structure of the regular geometry. Urban area have low vegetation, but the periphery of the urban area show the presence of the vegetation by varying shades of red color. Gardens or landscapes area appears in bright red color. Industrial area is associated with the dumped raw material, waste disposal area and many vehicles for the transportation. Water appears dark gray to black shades. Deep water will be dark than the shallow water, as deep water absorbs more energy. Turbid water will appear in light tone compared to clean water. Undisturbed water will have smooth texture. Next one is vegetation. Vegetation show red color for the infrared reflection and blue color for the green reflection in standard FCC image. Cultivated fields show bluish red color. Coarse texture appear for the forest area. Decaying yellow vegetation appears blue color. Forest area is associated with the hilly area and water bodies. Mangroves appear bright red and are associated with the coastal areas. Cultivated fields have regular geometrical boundaries and appear combination of the red for chlorophyll and black for water. ओके यहाँ पे मैंने सभी लिंक्स दी हुई है, उसमें से आप वीडियोस देख के आपको ज़्यादा पता चलेगा. ओके हम एक दो वीडियो देखते हैं.
Welcome to our Vision campus. Today I would like to talk about multispectral imaging. What does multispectral mean, and how can vision applications benefit from this technology? Multispectral cameras can see more than just colors. They capture image data within specific wavelength ranges across the electromagnetic spectrum. They can measure light in a small number of spectral bands, mostly between 3 and 15. There are also cameras that can capture hundreds of spectral bands. This is called hyperspectral imaging. The human eye can see electromagnetic waves with wavelengths between 380 and 780 nanometers. Electromagnetic waves with wavelengths outside of this range, such as infrared, are invisible to humans. Multispectral imaging allows us to obtain additional information the human eye cannot see. There are three possible ways to gain spectral image information: a camera with optical elements, or a continuous filter like the filter wheel, or a CMOS sensor with a filter. Multispectral cameras with optical elements consists of a prism, a sensor, gratings, and lenses. The light enters the camera through a slit. The prism and gratings refract the light. The line scan sensor can then generate a multispectral image, line by line. One disadvantage of this scanning type is that the performance strongly depends on the alignment of the optical elements. Calibration is crucial and can be very costly. Objects captured by filter wheel cameras are scanned sequentially because the camera captures single wavelengths. For additional wavelengths, the filter wheel must be moved to the desired filter. This results in a reduced scanning speed and therefore is not usable on moving targets. Now there are also CMOS sensors with band filters integrated into the sensor's layout. Compared with the other scanning types, cameras with spectral filters on CMOS sensors have no optical parts which require alignment. They can capture objects with different wavelengths in one single shot. These sensors are much more affordable and easier to integrate into a vision system. Up until a few years ago, you would find multispectral cameras mainly in aerospace and life sciences applications, as well as in labs. The equipment was very large and very expensive. Today, the cameras have become significantly smaller, but they are still expensive. Prices of more than 10,000 euros aren't unusual. The market can afford these prices. The demand continues to grow, and there are no inexpensive alternatives yet. Multispectral cameras are used for printed circuit board inspection, counterfeit detection on banknotes, and skin characterization and dermatology. The main applications for multispectral cameras, however, are in the food industry. It starts on the farm. Multispectral images help the farmer to determine whether the crop is healthy or not. A drone equipped with a multispectral camera flies above the field and collects the image data. The data is then wirelessly transmitted to a computer on the ground. The farmer sees the data on a computer in different colors, for example red and green. If the red area marks sick plants, the farmer knows which precise areas need to be sprayed with pesticide. This has huge benefits for both the farmer and the environment. The farmer can save time and money, and healthy plants don't get unnecessarily sprayed. When we go to the supermarket, we expect our food to be of the best quality. To achieve this, there are automated processes during the food production, such as food sorting, for example. Multispectral cameras are able to detect foreign objects like debris, stone or dirt, which are difficult to differentiate using traditional cameras. Have a look at these apples, for example. Traditional RGB cameras can detect whether the apples are damaged or have red blemishes. Multispectral cameras, however, are able to detect even the slightest dent in the apple. They can see if one part of the apple is softer than others. As you can see, multispectral cameras can be used when you need more information than traditional RGB cameras can give you. They offer great benefits for many applications. Thanks for watching.
Hyperspectral imaging, like other spectral imaging, collects and processes information from across the electromagnetic spectrum. The goal of hyperspectral imaging is to obtain the spectrum for each pixel in the image of a scene, with the purpose of finding objects, identifying materials, or detecting processes. Much as the human eye sees visible light in 3 bands, spectral imaging divides the spectrum into many more bands. This technique of dividing images into bands can be extended beyond the visible. In hyperspectral imaging, the recorded spectra have fine wavelength resolution and cover a wide range of wavelengths. Engineers build hyperspectral sensors and processing systems for applications in astronomy, agriculture, biomedical imaging, geosciences, physics, and surveillance. Hyperspectral sensors look at objects using a vast portion of the electromagnetic spectrum. Certain objects leave unique fingerprints in the electromagnetic spectrum. Known as spectral signatures, these fingerprints enable identification of the materials that make up a scanned object. For example, a spectral signature for oil helps geologists find new oil fields. Figuratively speaking, hyperspectral sensors collect information as a set of images. Each image represents a narrow wavelength range of the electromagnetic spectrum, also known as a spectral band. These images are combined to form a three-dimensional hyperspectral data cube for processing and analysis, where X and Y represent two spatial dimensions of the scene and represents the spectral dimension. Thank you for watching. For more educational videos, please subscribe to Wiz.
Hi, in this tutorial we will shortly introduce what hyperspectral imaging is. A good way to work with materials, identify them, or define their properties is to study how light interacts with them. This study of light interaction with materials is called spectroscopy. Spectroscopy examines how light behaves in the target and recognizes materials based on their different spectral signatures. These spectral signatures can be identified from the spectrum of the material. Spectrum describes the amount of light in different wavelengths. It shows how much light is emitted, reflected, or transmitted from the target. To put it in short, the spectrum tells how much of a certain color this light contains. The usual way to present spectrum is a graph on a scale of intensity and wavelength. Spectral signatures can be compared to fingerprints. Just like fingerprints can be used to identify a person, spectral signatures can be used to identify material. Let's examine the reflected light in more detail. To study the light, one needs an instrument called a spectrometer. It's an instrument that splits the incoming light into a spectrum. In this example, the light going through a spectrometer is reflected, and the result is therefore called a reflectance spectrum. Measuring the reflectance spectra is the most common way to use hyperspectral imaging. Hyperspectral imaging uses an imaging spectrometer to collect spectral information. This device is also called a hyperspectral camera. With hyperspectral camera, we are measuring thousands or hundreds of thousands of spectra instead of single spectrum. The collected spectra are used to form an image of the target in a way that each image pixel includes a complete spectrum. By doing this, we are able to get answers to questions what, based on the spectrum, and where, based on the location. We can pick any position from the target to get the information. This means a big amount of accurate information. The data that hyperspectral imaging provides is called a data cube because the hyperspectral data is actually three-dimensional. We will use a book example in the next tutorial called What Hyperspectral Imaging Provides to explain it.